Okay, this is AP Calculus practice test from 2018. Multiple choice, starting with number 23. So that one says using the substitution U is equal to x plus 1 the integral x over the square root of x plus 1 is equivalent to what? So, all right, we need to, if u is equal to x plus 1, then u minus 1 is equal to x. Just move the 1 over to the left. So we could then rewrite this, and then x plus 1 is already u. We could rewrite this as u minus 1 over the square root of u. Okay, so what you could think of that as is u minus 1 over u to the 1/2. All right, and then divide 1/2 into each part of the numerator. Okay, so u over u to the 1/2 would be u to the 1/2. And then minus 1 over u to the 1/2 would be minus u to the minus 1/2. All right, and that is answer C. All right, so really not too bad. We've done a lot of U-substitution problems there, so good to go. (24) says we have a function f of x is equal to 2x squared plus 14x minus 16 over x squared minus 9x plus 8. So at what values of x do we have a removable discontinuity? And you can tell if a discontinuity is removable if you can factor it. Maybe it makes a 0 in the denominator, but if you can factor and cancel it, then it's a whole. And a whole is a removable discontinuity. So let's factor, see if with the top we could factor out a 2. All right, so in fact, let me go ahead and just, if we factor out a 2, we'd have x squared plus 7x minus 8. And on the bottom, if we factor that, we'd have x, and then minus 8 minus 1 would do it. Let's see what we got. So x minus 8, x minus 1. All right, we've got x, and then plus 8 minus 1. So you do have a discontinuity at x equals 8 and 1, but the 1 will cancel out. So that discontinuity is removable, and that is A. All right, so we haven't done that in a long time, not since the early part of chapter 2, but it's really not too hard. Okay, let's flip the page. I think I have room to put number 25 on here. So 25, we have, which of the following is the solution to the differential equation y double prime minus 4y is equal to 0? So what you have to do is just go through each one of the options, find y double prime, and see which one works. So let's start with option A. So it says y is equal to e to the 2x. So y prime would be 2e to the 2x, and y double prime would be 2e to the 2x times 2, so 4e to the 2x. So let's see if that works. So you'd have, for y double prime, you'd have 4e to the 2x. 4 times y is minus 4e to the 2x, right? Because e to the 2x is y. 4 times y would be 4e to the 2x, and that does equal to 0. So we don't have to look at options B, C, or D. Option A did it. Isn't that great when it works out to be option A? When it's option D, you got to work through all of them. Okay, so pause video if you need to. I'll erase. Okay, so we have x and f of x. So this is number 26. I'll go ahead and write out these values. So we have 10, 5, 11, 2, 12, 3, 13, 6, 14, 5. And it says between 10 and 14, we've got 2 critical points. All right, so which of the following must be true? Okay, let's just plot this. So 10, 11, 12, 13, 14. And the y values, we've got, say, 5. We'll call 5 up here. 6. And we can call this 3 and 2. Doesn't really matter if you have a nice to scale graph. All right, we got 10, 5, 11, 2, 12, 3, 13, 6. So that's the tall one. 14, 5. Okay. So let's look at option A. It says f of x is greater than 0 for everything between 10 and 14. Well, that's not necessarily true. There's nothing to prevent this thing from going below the x-axis on any of these. All right. It says it's continuous, but these are just particular points. Between 10 and 11, it can go below the x-axis and then come back up, right? 11 and 12, somewhere in there, it could go below. So that's not necessarily true. All right, how about B? F prime of x exists for all x. Okay, it is continuous, so there's not some kind of hole or a gap. But what if there was somewhere in there a sharp turn? Or a vertical section, vertical line? So that's also not necessarily true. It'd still be continuous if it had those issues. Okay, so not necessarily true. F prime of x is less than 0 between 10 and 11 for all x. Well, not necessarily true. Wouldn't be for all x. I mean, yes, if you could connected those two directly, it would be. But what if it went down below and then came back up somewhere between 10 and 11? So that's not necessarily true. So by default, it's got to be D. So, but let's at least explain D. You got f prime of 12 is not 0. Meaning at 12, you can't have a critical point. And that's because the critical points have to occur between 10 and 12, because see how it goes down like this? All right, and it has to occur between 12 and 14, but it can't occur. So that's just a guess. I mean, I know it could go below the x-axis, but it can't occur at 12 because 12 is in between a lower one and a higher one. So you can't have a slope of 0 at 12. It can't be a critical point there. So the answer is D. So that one required a bit of thinking through, and took you only have 2 minutes of problem for these, so you've got to work through that one a lot faster than what I did. All right, and the next one is also a long drawn out one. So here we go on that. Number 27 says the positive variables P and C change with respect to time t. Relationship between P and C is given by the equation P squared is equal to 20 minus C cubed. We know that dP dt is equal to 41, C is equal to 15. What is dC dt? I can tell you now, this is one that you do have the skills to do, but it would be one worth skipping and coming back to. All right, and you're not going to know that till you kind of start trying, but you've got to take the derivative with respect to t. Okay, so we got to get dC dt. All right, so that's going to be 2p dP dt is equal to 3 times 20 minus c squared times the derivative of the blob, negative 1 times dC dt. All right, so that's going to be 2p dP dt is equal to minus 3 times 20 minus c all squared dC dt. So dC dt, solving for dC dt, it's going to be 2p dP dt over minus 3 times 20 minus c all squared. We know dP dt is 41. We know c is 15. We got to get p. All right, so let's plug. We know that p squared is equal to 20 minus c is 15. So we're going back to that original equation, 20 minus 15 all cubed. So p squared is equal to 5 cubed. P squared is equal to 125. So p is equal to the square root of 125, which is going to be 5 times the square root of 5. So if you factored out a 5 here, you'd have the square root of 25, so 5 root 5. That's just simplifying it. Now let's plug in. dC dt is equal to 2. P is times 5 root 5, right? dP dt is 41. That's a butthole. Over minus 3, and then 20 times 5 squared. Okay, that's minus, so let's move the minus to the top, okay? So that's going to be 41 times 2 is minus 82 times 5 square root of 5 over 25 times 3, 75. All right, we could cancel that 5 and make that into a 15. So that's minus 82 root 5 over 15. Maybe as soon as you got to the 82 part, you could make a guess, but A could be, 82 is part of A and D. The answer is D, so you can see this is one you're really not going to be able to guess. You're going to have to work it out. So that's a wait till the end to work it kind of problem. You can do it, but it's easy to make a mistake along the way. All right, let's go to something faster and easier. (28). Okay, it says the limit as x approaches negative infinity of 3 plus 2 to the x over 4 minus 5 to the x. Let's go ahead and plug in negative infinity. That's 3 plus 2 to the minus infinity over 4 minus 5 to the minus infinity. Well, that's just 3 plus 1 over 2 to the infinity, right? If it's a negative exponent, you take it down to the bottom. Over 4 minus 1 over 5 to the infinity. Well, what is 1 over 2 to the infinity approach? That's just like 0, right? That's 1 over an unimaginably huge number. How about 1 over 5 to the infinity? Same thing, that's 0. So that's like 3 plus 0 over 4 minus 0, which is 3/4. And that is C. All right. Very doable. Okay, 29, I think I can fit it here. So we've got a graph. Got the line y equals x. And then we've got g of x that goes something like that, right? Okay, so this is y equals x, and the curve is g of x. And you want to know, okay, what's the area? Okay, and they cross at 1 and at 2, and of course at 0. Okay, so you know it's top minus bottom, so you know that the area is going to be from 0 to 1 of g of x minus x dx plus 1 to 2 of x minus g of x dx. So that is definitely one of the ways to get it, which is option 3. And unfortunately, it'd be easy to pick B, but if you read through it, option 2 also works, because in that case, what they give you is 0 to 2 of the absolute value of x minus g of x dx. That absolute value will make the area where this one would give you x minus g of x, this part would give you a negative, right? Because x is below g of x, but if you absolute value it, it'll make it positive. So that's another way to do it. Okay, so both 2 and 3 are correct. So that's a tricky one. So the answer is D. All right, that make a star, an asterisk, whatever you want to do next to that one. That one's worth studying. Number 30. A student attempts to solve the differential equation dy over dx is equal to xy cubed when y is equal to 2 and x is equal to 0. Which steps do we have a mistake? Where does the first mistake appear? Okay, well first we're going to separate the variables. So we'd have dy over y cubed is equal to x dx. And we have to integrate both of those. All right, that's cool. So step 1 is good. The answer is correct in that. Step 2, okay, this right side would be 1/2 x squared plus c. And the left side, you would rewrite this as y to the minus 3 dy. And so step 2 is wrong. That is not the natural log of the absolute value of y cubed, right? If it was dy over y, it would be natural log, but it's dy over y cubed. So this is going to integrate into y to the minus 2, right? And you would need a minus 1/2 out front, right? So it's step 2 where the first mistake appears. I don't know why I put a dot there, sorry. Step 2, and that is B. So hey, you could have got that one pretty quick. That's why you don't want to waste all your time on that one, number 27, that was so intense on the mental math. All right, you want to move past that and try to go back to it. So that covers the non-calculator portion of the multiple choice on the 2018 test. The next video will go to the calculator portion. So stay safe and corona-free out there.